Hello everyone. So welcome back to my lectures on the topic pair of linear equations in two variables. So we have covered the introduction part of this particular topic. So now let's get into our next part where we are going to discuss the methods of solving these linear equations in two variables. So this is actually part 1 of methods of solving. We are having few more which will be coming in the part 2 of methods of solving this pair of linear equations in two variables. So let's get into it. So the first way of solving this pair of linear equations is nothing but graphical method. So graphical method to solve a pair of linear equations in two variables. So this is our first and foremost method which we'll be seeing here. So you know how to plot a graph. You have a basic and overall idea how to plot a graph, right? So the thing how to find the solution using the graphical method is nothing but graph both equations using same pair of horizontal and vertical lines called x and y axis. So in the same x and y axis, so in the same axis we have to plot these both equations, right? And then coordinates of this point of intersection of these two lines is nothing but the solution. So if that pair of solutions has a solution, right, if there is a no solution means there is no, actually they won't intersect and all. So if there is a solution, then if after plotting these two lines on a graph, they both will be intersecting at one single point. So that is nothing but the solution of the given two lines or else for the given pair of linear equations in two variables. So now let's see a question based on this graphical way of solving. So the question here is, check whether the pair of equations x plus 3y equal to 6 and 2x minus 3y is equal to 12 is consistent. So first we'll start with checking whether the given equations are consistent or not. So a1 by a2 is nothing but 1 by 2 and b1 by b2 is nothing but 3 by minus 3 which is equal to minus 1. So from this we can state that it's according to our first condition where a1 by a2 is not equal to b1 by b2, hence the given pair of equations are consistent. So if so, solve them graphically. So they are consistent. So now here we have to solve these by using the graphical method. So first consider the first equation, x plus 3y is equal to 6, and for this let us take a tabular form for x and y values. So this is x and this is y values. So let us take two values. 2 will be enough to plot a graph. So 2x minus 3y is equal to 12. So same thing. So let's take a tabular box. So x and y and two values. So let us take our x is 0. So if x is 0, so substitute here. So if we substitute x is 0, our y will become 3y is equal to 6 and y will be 6 by 3 which is equal to 2. So at x equal to 0, the y value is 2. Similarly at y equal to 0, the x value will be 6. So same way let's check at x equal to 0 here, which means y will become minus 4. And the next point we can see here is at x is equal to 3. At x is equal to 3, what will be happening? So 12 minus 9 will be 3 and x will be, so here the another point we are having is, first one is, let us take 3. So if we substitute x is equal to 3, so here, so 6 minus 3y, so 6 minus 3y is equal to 12, so minus 6 is equal to 3y, where we end up having y equal to minus 2. So these are our two values. So let's plot the graph of these two equations. So the first one is 0, 2. So x is 0, y will be 2. It will be somewhere here. So let this be point A. And the next one is x is 6. So somewhere here, and y is 0. So let this be here point B. So point A, point B. So passing through this, we'll be having our first equation. So this is our first equation of a straight line, right? First graph of our first equation. So let's plot the next one. X is equal to 0 and y will be 4. So it will be somewhere here we might have. So let this be, name it as P. And similarly the next one is x is equal to 3 and y will be minus 2. Somewhere here it will be 1, 2, 3, 4, 5, 6, and here 1, 2, 3 and 4. So this will be, so if we plot this, so this end up, if we join this as a line, it end up intersecting this point B, if we actually use a straight line and draw it. So here our point or common point of intersection of these two lines is nothing but point B, which is equal to 6, 0. So let's check this point by substituting here. X is 6, so y is 0. Exactly, it satisfies both the equations. So hence the solution using the graphical method of the given pair of equations is nothing but 6, 0, that is nothing but x equal to 6 and y equal to 0. So this is our solution. So moving on to the next method of solving our pair of linear equations. So here it is a substitution method. So what is a substitution method? How we will be solving it? So consider these are our two pair of linear equations. So now let's see the steps in which this method how can be solved. So the first step is find the value of one variable. So let's say y. So one variable y in terms of the other variable. So that means our x from either equations, whichever is convenient. So whatever equations, so in the two equations, whichever is convenient, we can take that equation and we can write our x in terms of y, or else y in terms of x. So we'll let it be y in terms of other variable, that is x. So we'll express a equation y in terms of x. So let's consider that as a equation 3. And then substitute that y value, this value of y in another equation, and then reduce it in the form of x, which can be solved in single variable x, right? Which means in the given equation we will be expressing one variable in terms of other and taking that and substituting in the another equation. So using that we can easily find the values. So let's see and understand. So once we substitute that, what it will happen? Sometimes they will be having two conditions. So sometimes we can actually get statements with no variable. We cannot get the variable here. So then it's like if the statement is true, then we can conclude that pair of equations has infinitely many solutions, because we are actually finding this for a single solution. But what if there is no variable which states that it will be having infinitely many solutions? So if not, it's a false, then it will be, if the statement is false, then it will be a no solution. So instead of that, we'll just here focusing on the single solution part. So we'll be substituting, and then we end up after substituting one variable in terms of another and substituting in the another equation, we end up having a equation in a single variable, and we can solve that and find the values of our x and y. So let's solve a question here. Find the solution of the following system of equations by substitution method. So here if you observe, our first equation is 4x plus y is equal to 11. So I am converting this y is equal to 11 minus 4x. So this is my equation 1 and this is my equation 2. So let it be 3 and this will be my equation 2. Right. So I have converted my equation 1 in the form of equation 3, and now I'll go and substitute this equation 3 in equation 2. So x plus 2 in place of y, I'll be substituting this part. So 11 minus 4x is equal to 8. So now let's solve it. So x plus 22 minus 8x is equal to 8. So minus 7x is equal to 8 minus 22. So 8 minus 22 is equal to minus 7x. So minus 7x will be equal to minus 14, and minus will, or else x will be equal to minus 14 by minus 7, which is equal to 2. So the value of x by solving here is nothing but equal to 2. So now we will substitute this x value in the equation 3. So y equal to 11 minus 4x. So equal to 11 minus 4 into x value is 2. So 11 minus 8 will be equal to 3. Hence the y value for this pair of equations is equal to 3. So here our solution for this given pair of equations using the substitution method is nothing but x equal to 2 and y is equal to 3. So let's solve one more question based on the substitution method. So here the equation is x plus 3y is equal to 6. So let it be equation 1. So 2x minus 3y is equal to 12. Let it be equation 2. So now I am converting my equation 1 such a way that x is equal to 6 minus 3y. So let this be equation 3. So now substitute our equation 3 in place of x in the equation 2. So 2 into, in place of x I am substituting equation 3. So 6 minus 3y is equal to 12. So now let's simplify it. 12 minus 6y minus 3y is equal to 12. Right. So 12 minus 9y is equal to 12. So where we end up having minus 9y is equal to 12 minus 12, 0. So 9 is equal to 0 by minus 9, which is equal to 0. So the value of y here is 0. So now substitute value of y here. So which is equal to 6 minus 3 into 0 is equal to 6. So hence the solution using the substitution method for this given pair of linear equations in two variables is x is equal to 6 and y equal to 0. So this is our first part of solving pair of linear equations, like methods of solving. So in our next part we will be seeing few more methods. Thank you.